Hello everyone, welcome back to this YouTube channel IBwontcrushyou, and today we are dealing with points in space. And before we start, you can read in the description about a small contest. Problem 1. Points are given as A 2, -1, 4, and B -3, 2, 1. A. Find the length of segments AB. So here we have to use our booklet where we have the formula for distance between two points, and this is the formula from the topic Geometry and Trigonometry, where we have three coordinates, so x, y, and z. So this is the formula, and now we have to substitute our values. So x1 is 2, so 2 minus, and x2 is -3, so -3 and squared, plus y1, so -1 minus 2 squared, plus 4 minus 1 squared, and we can type it into our GDC and calculate the distance. So our distance is 6.56, and we are not given the units, so we have to write just units because we don't know if our units are meters, centimeters, kilometers, so we have to leave it like this with just units or U. And point B, find the midpoint M of AB. So here we have to use our booklet, or basically the formula for the midpoint is very easy. So it's basically x1 plus x2 divided by 2. It's like calculating the mean. So we are adding x's and we are dividing them by the number of them. So 2 x's we are dividing by 2. The same goes with y's and z. So, but you have it in your booklet as well. It's called coordinates of midpoint of a line with endpoints, x1, y1, z1, x2, y2, and z2. So it looks like this, and now we just have to substitute our values. So 2 plus -3 divided by 2, -1 plus 2 over 2, and 4 plus 1 over 2, and we have to calculate it. Basically, we know the answers already, so here we have -1 over 2, then we have 1 over 2, and the last one is 5 over 2. So this is our midpoint M of AB. And C, the point C, 0, 1, 2, is given. Decide whether C lies on the line segment AB. So in this type of exercise, we will check whether our vector AC is a scalar multiply of vector AB with scalar t, and our t will be from 0 to 1. So firstly, let's calculate our vector AB. So our vector AB is this minus this, our first coordinate. So -3 minus 2. The second coordinate is 2 minus -1. So 2 minus -1. And the third coordinate is 1 minus 4. So our vector AB is -5, 3, and -3. And now we have to calculate our vector AC. C in the same way basically. So C has first coordinate 0, so 0 minus 2, then 1 minus 1, and then 2 minus 4. So the coordinates of this vector are minus 2, 2, and minus 2. Now we have to check if our vector AC is any multiply of vector AB. So we can write it down like this. AC, this vector, is T, so our scalar times vector AB. So minus 2, 2 minus 2 equals T times our vector AB, so minus 5, 3, and minus 3. So we have to calculate each, basically we have to calculate the scalar for each coordinate. So firstly, minus 2 equals T times minus 5. So in order to have T, we have to divide both sides by negative 5. So here we are left with 2 over 5 equals T. Now the second coordinate, so 2 equals 3 times T, and in order to have T alone, we have to divide both sides by 3, so 2 over 3 is T, and the third coordinate, so minus 2 equals minus 3T, and we have to divide both sides by negative 3, so 2 over 3 equals T. So here we have the same T, however here we have different T. So these T, these letters just disagree, so our point C is not on the line AB, so not on the segment. Problem 2, the vectors are U equals 2, minus 3, 1, and V equals 1, 4, and minus 2. A, compute the angle between U and V. So this problem is more for HL, because here we'll be using formulas that are only in HL section. So if you are SL, you can skip this problem. And yeah, we have to compute the angle between U and V. So in the booklet, you can find the section Geometry and Trigonometry, and there is one formula that is called angle between two vectors. So we are given vectors U and V, and we have to compute the angle between these two vectors. So basically all we need to do is find appropriate formula. However, our formula has description angle between two vectors, so we already know the formula, and then just substitute everything into this formula. So firstly, let's rewrite this formula. So this is the formula, and in order to calculate this V1 times W1 plus V2 times W2 and so on, we are also given in the booklet scalar product, and then there we have V and dot W, and this equals to this. So we can firstly rewrite this formula for scalar product. So this is it, and this is basically the multiplication. So 2 times 1 plus minus 3 times 4 and plus 1 times negative 2, and this is minus 12. So we have the value in our numerator, and now we have to calculate what we have in the denominator, and it looks like absolute value. However, this is magnitude of a vector, and also you have it in your booklet. The formula is called magnitude of a vector, and it looks like this. It's very similar, it's calculated very similar to the distance. It looks like this, and now we have to substitute our values from v and u. So this is it, we have our answers, and now we can substitute them into our formula. So in the numerator negative 12, and in the denominator square root of 21 times square root of 14, and here we can leave them as roots because this is not the final answer, so this is exact value, and our final answer we can leave in the standard form. So here we can leave square roots. So this is it. And now in order to calculate, we can divide both sides by cosinus, because we want to have just this angle. So our angle equals, and we remember that we cannot divide by this cosine, so we have to multiply, because this is the same. So we have to multiply it by 1 over cosinus, and this is the same as cosinus to the power of negative 1. So basically we have to type something like this into our GDC, and we will find sorry, not square root of 12, 21, and we can find our final answer. And our theta angle is 134 degrees. B. Comment, are the vectors closer to being parallel or perpendicular? So we can observe that our theta angle 134 is an obtuse angle, so it's slightly closer to 90 degrees than to 180. So the vectors we can say that are marginally closer to perpendicular than parallel, and we can write something like this. Problem 3. The plane has equation x plus 2y minus z equals 4. A. Show that the point P 202 lies on this plane. So as you may expect, we have to just substitute these values into x, y, and z, and if they satisfy the equation, thus the point P lies on this plane, and if not, it doesn't lie. So simple as that. So 2 plus 2 times 0 minus 2 equals 4. So here we have 2 plus 0 minus 2 equals 4. So 0 equals 4, so it's not true. Hence, it doesn't lie on this plane. B. Find the perpendicular distance from point Q115 to the plane. So from this point to our plane. So firstly, let's write our general formula. So ax plus by plus cz equals d. So we can identify our coefficients from our plane equation. So a is 1, b is 2, and z c is minus 1. So these are our coefficients, and the perpendicular distance has an equation, and you can observe that this formula is very similar to the angle between two sectors formula. However, here we have distance, and it kind of differs. However, it's very similar because we calculate many things in the same way, and our numerator calculates how far the point is, let's say, of the plane in the direction of the normal, and the denominator normalizes by the magnitude of the normal vector, so that we get the actual perpendicular distance. And now we can substitute our values. So let's firstly deal with our numerator. So this is a times our first coordinate from our point Q, so 1 times 1, then we have to add 2 times 1, then minus 1 times 5, and we have to subtract d, so our d is 4, so minus 4, and the answer is minus 6. And now we will deal with the denominator. So here we have square root of 1 squared plus 2 squared plus minus 1 squared. So this is square root of 6. And now we can substitute them into our distance formula. And here we have absolute value of negative 6, and here we have square root of 6. So our final answer, we have to calculate it on our GDC, is 2.45. And of course units, because here we are not given the units, so units. Problem 4. A tetrahedron has vertices at A, B, C, and D, and we are given the coordinates of them. A, find the area of triangle BCD. So, of course, here we can use a formula from our booklet for the area of a parallelogram and take half of it in order to calculate the area of triangle. However, here I will show you a more easy way, but firstly let's draw this tetrahedron and make sure that you understand the basis of it. So this is our tetrahedron. Our vertex is D because it has a Z coordinate other than 0. A is in the origin because it has coordinates 0, 0, 0. B has x2, so in here, and C has y3, so in here. And this is our coordinate plane with 3 coordinates, so x, y, and z. And we have to find the area of triangle BCD. So basically this side, let's say this wall of our triangle, so we can redraw this triangle. So this is our regular triangle, and we know that in order to find the area of this triangle, we have to multiply half with A and with H. So we can simply find the distance between B and C. So this will be our A, and then distance between D and this point. But this point is just our midpoint. So firstly, maybe let's calculate this midpoint. So midpoint of B and C. So this is 1.5 and 0. So this is midpoint of BC. Now we can calculate distance between A and B. A and B. Sorry, B and C, in order to have A in our area formula, and then distance between midpoint and D. So now we can substitute our values. So these are our distances, and now we can substitute them into our area of triangle formula. So 1 over 2 times a, so times our distance BC, times square root of 13, and times square root of 77 over 2, and this is equal to 7.91 units squared. So I think that this was easier way than calculating it from the vector product and area of parallelogram, because you have to just understand it, and then it's easier than you may think. B. Find the volume of the tetrahedron ABCD. So as you can observe from our image, point A has coordinates 0, 0, 0, and the rest has at least one digit other than 0. So we can treat BCD, this triangle, as base and A as a vertex. And in order to calculate the volume in the, let's say, easy way, we have to just multiply 1 over 6 with the determinant of vectors AB, AC, and AD, or we can do it in the easier way. So we have to calculate 1 over 6 with product of the intercepts. This is our first method, and in order to calculate vector AB, we have to subtract from B A. So 2 minus 0 is 2, 0 minus 0 is 0, and 0 minus 0 is 0, so 2, 0, 0. Then we have AC, so 0 minus 0, 3 minus 0, and 0 minus 0, and AD, 0 minus 0, 0 minus 0, 4 minus 0, so 0, 0, 4. And the determinant of them, we can observe that here we have only 2, here we have only 3, here we have only 4. So without calculating it like precisely, we can say that the determinant of it is 2, here 3, here 4. So 1 over 6 times is times 2 times 3 and times 4. This is 24 over 6, so 4. And the easier way is just 1 over 6 times and product, so we have to multiply points of intersection. So here, 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 so 2, 3, 4, 2, 3, 4, and the answer is the same, 24 over 6, so just 4. C. A student claims that triangle BCD is a right triangle. Verify if this is true. So basically we are talking about this triangle from our point A. And we can see that this triangle is not right angled, but we have to verify if this is true. However, we know that it's not. But we can, for example, use a Pythagorean theorem and just show that a squared plus b squared doesn't equal c squared. So we have already calculated this side, and this is a square root of 13. So let's calculate distance BD and distance CD. So these are our distances, and now we have to use Pythagorean theorem just to prove that this triangle is not right angled. So let's write the equation. So square root of 13 squared plus 2 square root of 5 squared equals 5 squared. So here we have 13 plus 20 equals 25. So we know that's not true. So our triangle is not right angled. Problem 5. A drone is hovering at point D 0050 above the ground. Two observers are standing at the ground level. Observer P with coordinates 30, 0, 0, observer Q with coordinates 0, 40, 0. A. Find the angle of elevation from each observer to the drone. So let's firstly recall what's angle of elevation. So when we have an angle like this, so here is ground, here is, for example, airplane, and we're standing here and we see this plane. And the other situation when we have angle of depression, so when we are in the airplane and, for example, we see some people walking on the ground. So we have drone, let's suppose it's in here, and we have two people, P and Q, two observers. So the first observer will be in here and the second one will be in here. It's our diagram, so it's not necessary in here, so don't worry about appropriateness. It can look as you want, just to help you imagine the situation. So here we have observer P, here we have observer Q, and here is distance 30 and here 40. And here we have height of 50. So here we have 50, here we have 30, and here we have 40, and I know that P has x coordinate 30 and Q has y coordinate 40. However, it's not the case in here. We just know that in here is our origin 0, 0, 0. Our drone has 0, 0, 50, so z is 50, so it's our vertical height, and x and y are just horizontal distances. So we can draw our image like this, and here we can observe that we have two triangles, and we have to find the angle of elevation from each observer to the drone. So from this observer and from this, we have this distance, we have this distance 30, we have this distance 40. So now we can of course calculate the hypotenuse for each observer from Pythagorean theorem. However, we can use this short formulas SOH, CAH, and TOA. And to calculate this, we have opposite and we have adjacent. So tangent, opposite, so 50 over 30. So this is, let's check, this is so maybe let's write in here that our angle is 59.036 degrees. We can leave it like this, and our beta angle is also tangent, so opposite 50 over adjacent 40. and this angle is 51.340 degrees. Of course, we can round it to three significant figures, so 59.0 degrees, and in here 51.3 degrees. B. Find the distance between the two observers as they stand on the ground. So all we need to do is just to find, or maybe you remember, the formula for the distance between 2 points with coordinates x, y, and z. So this formula, or we can substitute these values without rewriting the whole formula. So this is x coordinate of q minus x coordinate of p. So 0 minus 30 squared plus, and now y, 40 minus 0, and of course squared, plus 0 minus 0, so it's basically 0, so yeah, and this is square root of 2500, so 50. Distance is 50, and we can write u as units because here we are not given the units. C. A signal beam travels from the drone directly to the midpoint of segment PQ. Find the length of this beam. So firstly, we have to calculate the midpoint. Midpoint is just half of this segment. So of course we can use our booklet. In our booklet we have formula for the midpoint between 2 points. However, I think that it's very easy formula, so you can remember it. So we are just adding up firstly x's, so 30 plus 0, and we divide by the number of numbers, so 2. Then we have 0 plus 40 over 2, and 0 plus 0. Here we have to write 0 plus 0 because this is our coordinate, so we cannot miss it. And our midpoint is 15, 20, and 0. And now we have to find the distance. So the distance has to be from the drone to the midpoint. So once again we use distance formula, and we have to substitute our values. So 0 minus 15 squared plus 0 minus 20 squared plus 50 minus 0 squared, and this is square root of 3125, so it's approximately 55.9, and of course units. Problem 6. A sphere has equation, and we are given this equation. A line is given by r, and we are given this equation. A showed that the center of the sphere lies on the line. So firstly, let's say what these brackets mean. So the first one is our starting point, and the second bracket is the direction vector. So if we want to check if the center of the sphere lies on the line, we have to just substitute 0 as t. So r of 0 equals, in bracket, 2 minus 1, 3. And here we have 0 in front of our bracket, so basically this bracket is 0, so r equals 2 minus 1, 3. So we show that the center of the sphere lies on the line. B. Find the points of intersection of the line and the sphere. So let's write down our parametric coordinates from our line, but firstly let's rewrite our line in the other form, so we can also write it down like this, plus t, and here this. So this is our first coordinate, so x, 2 plus t. This is our y coordinate, so minus 1 plus 2 times t, and the z is the last one, so 3 minus 2t. And now we have to plug it into the sphere, so into this equation. So we have x, so in here we have y, so here, and z here. So this is the equation with substituted values, and as you can see, many values cancel out here, here, and here. So we're left with t squared plus 2t squared plus minus 2t squared. So, and it equals 25. And this is t squared plus 4t squared, because we have to also raise to the second power 2. And plus 4t squared equals 25. So we have 9t squared equals 25, and we can solve it on our GDC in solver, or we can divide both sides by 9. So t squared is 25 over 9, and now we have to take the square root of both sides. So t is 5 over 3, or t is negative 5 over 3. And now we have to substitute this t. So these are our coordinates after t substituted, 5 over 3 and minus 5 over 3. So these are our points of intersection. And that was the last problem from this topic, points in space. And if you found this video helpful, useful, you can leave thumbs up, subscribe to this channel, and in case of any questions, you can reach me out in the comments down below, or via my mail, that is as always in the description of the video. And in the description you can read about a small contest. Bye!